This is the Milky Way. This is just a part of our universe. Our galaxy is not the only one seen in this universe. It is neither much smaller nor much bigger than the other galaxies. Our universe is so unique that there are galaxies found here that are millions and billions of times bigger than the Milky Way, and at the center of all these is what drives these giant galaxies. There is a supermassive one. Black holes, the masters of darkness, are one of the greatest mysteries of this endless universe from what we know so far. They have always fascinated us all, so mysterious and vast that their power hardly needs describing. These cosmic giants, often described as terrifying, hide at the centers of galaxies. These giants have been visible to us in the history of the universe since the universe has existed. Scientists, in fact, we see them in the history of the universe since the time the universe came into existence. Recently, scientists have found some evidence that suggests black holes are present in our universe. Black holes existed in the early universe much earlier than we thought, and this discovery could change our understanding of the early universe. After all, what were these mysterious objects doing in the universe at the very beginning? How did they form so quickly, and why? After all, how did their evolution happen in that early universe? Astronomers have long been puzzled by the presence of quasars in the early universe. The discovery of quasars in the early universe means the presence of supermassive black holes there, and this conclusion surprised scientists even more. How could these holes possibly form when they didn't even have enough time to grow and evolve? Does that mean they were born as these extraordinarily massive giants from the very beginning? Or did they somehow learn to grow very rapidly, breaking the laws of the universe? Using data from the Hubble Space Telescope, a study was published in the astrophysical journal Letters. They learned to grow rapidly. Using data from the Hubble Space Telescope, a study has been published in the astrophysical journal Letters. And this study revealed that the early black holes were less luminous and were growing in a universe filled with darkness. Because of this characteristic, they have managed to escape our notice until now. This astonishing discovery not only deepens this mystery even further, but it is also providing us with a lot of new information about the formation of black holes. Let's go on a journey into black holes today and see how these black holes were forming in the early universe. We will also take a look at what the James Webb Space Telescope has told us about black holes. So get ready for an exciting journey full of the mysteries of this universe. How did black holes come into existence so soon after the Big Bang? In science, this is one of the biggest and most mysterious puzzles of the universe so far. How did black holes come into existence so soon after the Big Bang? Quasars, which are some of the brightest objects in the early universe, are powered by giant black holes. In these years, scientists have observed quasars in galaxies present in the early universe when the age of the universe was not even 1 billion years. If I ask you whether you have seen an old man who's only 10 years old, you would say, "Brother, how can someone become old at the age of 10 after being born?" Scientists are also puzzled by this very question. If they had so little time, how did they become so big so quickly? When it comes to black holes, they grow by swallowing the gas, dust, and other things around them. All this matter falls into the area of the black hole's disk and then slowly gets absorbed into the black hole. As this matter falls into the black hole, it collides with the other matter present in the accretion disk, which causes friction and heats it up. Because of this, all the matter in the accretion disk reaches a very high temperature, which causes intense radiation to be released from the entire accretion disk. This radiation creates a pressure barrier and puts a limit on the black hole's matter consumption, which directly affects the growth of the black hole. Considering this limit, scientists are unable to explain how, even with this limit in place at that time, it happened in such a short period. How did black holes become so massive after all? The two possible solutions given by scientists are as follows. Either these giant black holes must have formed from a stellar mass black hole, which is the remnant of a massive star. Since massive stars die very quickly, this path takes less time to reach the supermassive black hole stage. But if this process speeds up a little, then they can grow within a given limited time. Now, because they start off with a mass 1,000 times heavier than our sun, that's why they're also called heavy seeds, and because of this, they reach a large size quickly. But where did these heavy seeds actually come from? One theory suggests that dark matter halos are structures made of invisible matter that hold galaxies together. These structures are they also trap gas clouds in large quantities and prevent those clouds from turning into a star. When stars do not form from those gas clouds, they directly collapse into a black hole, which leads to the formation of a large heavy seed. However, the problem still remains. Only a few dark matter halos have been found to be large enough to trigger direct black hole collapse, forming black holes in the early universe in this way. They should be found in very small numbers in the early universe because the dark matter halos that create them were themselves quite rare. But recent research shows that the number of black holes we have observed in the early universe is much higher than our calculations predicted. And because of this, astronomers are now forced to believe that some very mysterious forces were at work in the early universe, which our current science still cannot understand. Now, how can there be black holes without any mystery surrounding them? Black holes and JWST discoveries. Because of advanced technology, astronomers are now able to find black holes hidden in galaxies present in the early universe. Earlier, we could only detect those bright quasars because they are very bright. But recently, observations from the Hubble Space Telescope have discovered many faint black holes that had remained hidden from us until now. Scientists monitored 15 years of brightness data. This has enabled them to estimate the black holes that are quietly growing in the universe. This method has given us new data which shows that the number of black holes we previously assumed, in reality, their number in the early universe is many times higher. The James Webb Space Telescope has taken this discovery even further. Thanks to its extraordinary sensitivity and advanced spectroscopic capabilities, JWST has also started detecting faint black holes in the early universe. It is closely monitoring their activities. This telescope is also capable of detecting the faint glow of black holes hidden within galaxies. This will help astronomers refine our early models of the cosmos. But then this raises another question. If so many black holes existed at that time, how did they all grow so quickly? After all, where did so much matter come from for them to consume? According to scientists, the answer to this might be hidden. In terms of variability in their feeding times, black holes, unlike stars, do not grow continuously. Instead, they leave gaps between feeding periods, they take breaks. Because of this, it becomes difficult to estimate what the actual rate of their size increase is. Black holes trick us here as well. This discovery is also groundbreaking because it contradicts our previous model. Scientists now believe this. Now they accept that all the black holes discovered so far, from the extremely bright quasars to the recently discovered less bright black holes, there are so many of them that they couldn't all have formed from direct collapse. This shows that there must have been some extremely mysterious processes at work during that time, which were creating not only large black holes, but also huge numbers of them. In the coming 5 years, the James Webb Space Telescope is going to play an important role in solving this cosmic puzzle. Its ability to observe faint black holes also gives scientists the power to witness the death of the earliest stars. And this event can tell us where the initial seeds of black holes came from in such large quantities. And how did the universe continue its journey? Apart from the standard theories of black hole formation, scientists are now considering even more bizarre ideas to somehow explain the black holes of the early universe. And one of these bizarre ideas is the concept of dark stars, although dark stars are completely hypothetical, meaning they are imaginary. This star forms when a large cloud of gas begins to collapse, just like a normal star forms. But when dark matter is present during that normal star formation, something mysterious happens. As the gas in the cloud contracts, something unusual occurs. It captures a large amount of dark matter particles, and these particles modify the internal structure of the star that is about to form in such a way that the process of nuclear fusion at its core stops, which is what makes stars shine. Without the fusion process, this star cannot shine like a normal star, but it lives much longer than those stars and becomes extremely massive. And eventually, these stars collapse under their own weight and turn into a black hole, which is much larger than any normal stellar mass black hole. If these objects existed in our early universe, they could explain why we've observed so many black holes. However, dark stars are still a theoretical concept for us today, an imaginary idea. But large telescopes like JWST can play an important role in proving the existence of such stars. Observing those early stars with our telescope can tell us whether dark stars played a major role in black hole formation in the early universe or not. This adds another exciting possibility to the growing list of questions about these black holes. Are there some processes at work in the universe that we haven't fully understood yet? The future of black hole research holds great promise for such fascinating discoveries. In just the past few years, there has been a new revolution in research in this field. Upcoming missions like the Euclid mission and the Nancy Grace Roman Space Telescope will help not only in observing faint black holes, but also in detecting faint quasars. Observatories like the Square Kilometre Array in Australia and South Africa will deepen our understanding of black holes, but currently, JWST leads this research. Observatories like these will help us understand all black holes in greater depth, but for now, JWST is leading this research. By observing some of the faintest black holes in the early universe, it is helping us refine our old models. In the coming years, with its help, we will even be able to find a star collapsing, and when that discovery happens, it will be historic. We are trying to learn and understand our own history, but we keep moving forward. Perhaps the universe is such that whenever we get close to understanding its origin, we are left amazed. As we go deeper into the journey, new questions arise before us. This is the reason why black holes, with their terrifying appearance, both amaze and trouble scientists. Common sense says that once. After entering a black hole, things undergo a terrifying amount of compression. After that, they get stored at its central point, known as the singularity. But is it really that simple, or is there something more to it? Well, we'll find out all about this in today's documentary, so stay tuned till the end. So friends, what if I tell you that scientists have found a way through which we can peek inside these black holes? Why? You won't believe it, right? But you have to accept it because something has happened that has forced even us to say this. Let me explain it to you. Let's go back a little. So here it is. There is a black hole called M87 located 580,000 light years away from Earth. Last year in 2019, which we saw for the first time in 2019. Well, if we focus on this first ever image of the black hole, then yes, right in the center of this picture, you'll see a dark blind spot. Actually, this is nothing else but actually the M87 black hole with the accretion disk around it. This accretion disk is clearly visible in the image, boiling around the black hole. We see a bright plasma ring with the black hole and its singularity inside. In 2019, we imaged the accretion disk around the black black hole, not the black hole itself. The black hole remains invisible to us, but we didn't capture an image of the black hole, but rather a picture of the accretion disk revolving around it. It means the black hole is still invisible to our eyes, but we have a clear-cut boundary. Actually, in the beginning, we didn't even have this so-called clear-cut boundary. But later on, when scientists realized that the accretion disk visible in the final image of the black hole was quite blurred and hazy, it was further refined to make it clearer. In this process, researchers created a light ray simulation in which they picked out the precise boundary from the image of the black hole and further refined it. The image was cast on a screen, which looked something like this. Doesn't it look a bit like the eclipse view you see during a solar eclipse? This view will help us peek inside the black hole. How is that? Let's see. In the United States, Cornell University is conducting in-depth research on this topic. According to scientists, a black hole is quite mysterious. It isn't actually the way it appears to be. That means the black hole you are seeing is not just a black hole. The real black hole is only in this small region. The large darkness you see after that is actually a photon ring. This specific area exists in the shadow region of the actual black hole. Although it is not a black hole, it still possesses some properties similar to it. For the existing black hole, this cycle is a dark zone. Here, matter and light's photon particles get trapped, after which they start orbiting it. To understand this better, look at the operation and cycle of a black hole. Whenever any matter particle comes to get engulfed by the black hole, it first waits in this area. This area is a high temperature zone because here matter boils and turns into a gaseous state. More specifically, it becomes plasma. After that, it moves forward and encounters this photon ring. You can also understand it as falling in. Friends, I'm sure you must be familiar with this basic concept of light. And if you're not, let me tell you that light is an entity that at the same time holds both wave and matter properties. Where the ray optics branch of physics has accepted it as an electromagnetic wave, the photons present in it also make it recognizable as matter. Strange, isn't it? The entire foundation of photoastronomy is based on rays of light, so always keep this in mind. And the photon particles also make light recognizable as matter. Strange, isn't it? The entire foundation of photoastronomy is based on rays of light, so thank you very much. Keep in mind that the behavior of light varies from case to case, from condition to condition. So back to the photon, it's nothing else. Actually, it's the area around the black hole where matter crosses the threshold of the black hole. Usually, matter and light pass through this area into the black hole, but many photons also begin orbiting the shadow area known as the photon ring. While orbiting, after a photon completes several orbits, it drifts into free space. Now, because this area is the actual black hole, and while orbiting it, when a particular photon completes a certain number of orbits, it drifts off into free space. They travel in a straight line until an object with massive gravitational influence comes in their way. But obviously, when photon particles travel in such a vast universe, sooner or later they will encounter something. Now, because this area is the actual black, inside such a hole, there is no curvature, so there is no bending. Here, when the light rays manage to escape, then it is absolutely possible for the light to reach an observer's telescope. In such a case, due to the curvature forming in space-time, the light will have to bend. Anyway, after overcoming all these obstacles, when this light finally reaches an observer's telescope across the universe, then an image will be formed from it. The light will also experience phenomena like spots, bending, or reflection, so in such a case, we will have visualizations of all these places. That means, can we study the entire universe with the help of photons coming from a black hole, or more precisely, from the image formed by them? Just imagine what a view of the whole universe that would be. But to do this, we will need some extremely powerful telescopes and supercomputers. With their help, we can not only capture this light but also process it to obtain high-resolution results. And that is, in this way, we can not only observe the universe but also see the inner parts of a black hole. Now you might ask, how is that possible? So the answer lies in this research paper released by Cornell University. This research paper explains how photons drift away from the photon ring. With these photons, we can see an in-depth view of the black hole. Actually, the shadow area of the black hole where our photon rings exist is an amazing place where a lot of quantum information related to that black hole is stored. To understand this more practically, you just need to know what is a black hole. Now, in such a situation, when these photon particles actually start moving from there, for sure, they will also start carrying snapshots of those inside views of the black hole along with them. While these things may seem simple and interesting, they're actually much tougher and more complex. Even if most of the things we are hypothetically imagining actually stand up to the tests of physics, it would still be extremely difficult to extract those views from those photon particles. In fact, as of today, we don't have any technology that actually exists which can practically do all this work for us. So for now, these things are just ideas. But there's quite a bit of truth in these things as well. Well, these black holes are an integral part of this universe. No matter how terrifying they are, no matter how massive the destruction they can cause, but their role in keeping this infinite universe in motion of this infinite universe cannot be denied. Black holes are an ultimate truth of this universe, which no one can deny. Until 2019, this was merely the name of a mathematical abstraction appearing in astrophysical theory. But today, these are recognized as real celestial objects. Their number in this universe could range from hundreds of thousands to tens of millions. Recently, scientists observed some strange activities in a galaxy which indicate a terrifying collision between two black holes happening there. This galaxy, named SRSJ 1430+2303, stands as evidence. Two black holes, each about 1.1 billion light years away from us and weighing as much as 200 million suns, are about to be destroyed. On the scale of cosmology, this massive collision is a distant event. The time it takes for it to happen is quite short. However, in real life, it will actually take a considerable amount of time for this event to occur. Scientists have suggested that these black holes will take about 3 years to completely collide and merge into each other. If we set aside the terror of destruction for a moment and look at this as a research opportunity, it will be a landmark point in the entire history of astrophysics. Here, we humans will witness an event that is not only super rare, but also something that very few people ever get to see. But there is a problem here, and that is, even now, scientists are not 100% sure about this. That in fact, what we are imagining is really going to happen in galaxy SRS J1430+2303. By the way, there is a little confusion about this, but our understanding so far tells us that we are moving in the right direction. A few years ago, in 2015, scientists observed some small black holes in space that were extremely close to colliding with each other. During the observation of these black holes, a striking pattern of cosmic catastrophe emerged. As a result, scientists learned a lot about the behavioral changes of these massive bodies present in the space fabric and the action of gravitational waves. A dedicated gravitational waves observatory has also been established to study the gravitational disturbances and waves generated by black holes, which houses the most modern and advanced gravitational wave detection instrument to date. Of course, for an ordinary person, witnessing these catastrophic events happening in space would be a terrifying experience. But for the researchers working on such observations, it's just part of the job. Witnessing any massive black hole collision or impact explosion is an absolute treat for these detectors, because after that, they get all the information related to that event, which proves to be very helpful in enriching their scientific database. If, for a moment, all our observational instruments fail to detect those waves, which have been generated due to these collisions, then in that situation, many facts can still be extracted through visual study. As I said earlier, light has an amazing significance in space, especially from a research perspective. Light is very important because whenever such massive events occur, a huge explosion is created, which releases a huge burst of light, and when we capture this light in our telescopes and read and understand its data, we find out exactly what is happening there. Through the photometrical investigation of the entire event, we learn fascinating things about the collision, impact, and the physics related to both objects. For example, when these phenomena were investigated in depth, it was found that the event of black holes merging doesn't just bring destruction. Rather, it also gives birth to a marvelous cosmic object. Obviously, after the merger of two black holes, a black hole is born, but it is many times bigger bigger and more destructive than before. I am sure you must be familiar with the basics of galactic mergers, and even if you are not, let me quickly tell you that in this universe, one galaxy also interacts with another galaxy, and when they come face to face in their paths, they merge. Galactic collision is one of the most dramatic events in this universe. In fact, this is the very event that provokes two giant supermassive black holes to collide with each other. Well, you all probably know that usually there is only one supermassive black hole at the center of a galaxy, and most of the matter in the galaxy revolve around it. So when a merger happens between galaxies, eventually the black holes of both galaxies also come face to face with each other. In such a situation, the weaker black hole surrenders to the stronger one and becomes a part of it forever. Astronomers have named this event a binary merger. To detect this, scientists study the fluctuations of light in a particular galactic cluster where objects are coming closer in decaying orbits. It makes the picture of black holes absolutely clear. The galactic nucleus, that is, the center point of the galaxy, is perhaps one of the strangest things in this universe. It is quite difficult to understand the signals coming from here. Also, the center of each distinct galaxy tells a completely different story, and to understand it, a new approach has to be chosen every time. Specifically, scientists in China conducted their research on this massive SRS J1430 plus 2303 galaxy, and for this investigation, they used X-ray wavelengths as the basis for their investigation, with the hope that through this, they would get a chance to understand the high energy waves coming out of the black hole. And to a great extent, they were successful in this endeavor. They tried to understand this massive black hole. Wave observation data from different observatories around the world, covering about 200 days, was collected. When the data was analyzed collectively, they found that there were changes observed in the light coming from the center of this galaxy. And this was only possible if two giant monsters were merging here. This fluctuation in light was only on a major scale, which rules out the presence of any other factor. And this proved that we have indeed witnessed the biggest black hole collision so far. As far as space catastrophe is concerned, black holes can definitely be one of the reasons for the destruction of our beloved solar system. In reality, they are so powerful that they have the strength to swallow entire galaxies. In that case, a small system like the solar system is nothing for them. Compared to a black hole, that's a completely different issue. If you're interested in knowing what would happen if a black hole came directly towards us and tried to swallow our Earth, that scene would truly be worth watching. Till now, some of the biggest black holes have been seen in this infinite universe. But a black hole as massive and powerful as this one has probably never been seen before. This hungry monster is one of the most active and dangerous black holes in the observable universe. You can get an idea of its hunger from the fact that it swallows as much material as the mass of our Earth every second. Since its birth, it has stuffed so much matter inside itself that its event horizon, or you could say its boundaries, have shifted quite far out. Its mouth is so wide that our entire solar system could fit inside it. Scientists estimate that this black hole is growing faster than any black hole formed in the last 9 billion years. The accretion disk formed from the boiling plasma around the J1144 black hole is brighter than all galaxies like the Milky Way. The amount of light coming from it is so high that it can be seen even with an ordinary telescope. That means the light of many galaxies and stars pales in comparison to it. In such a situation, the question arises, are we also close to such a dangerous black hole that could pull us in and destroy our entire planet? After all, how dangerous can these black holes be? Moreover, is there any such black hole within our solar system or nearby that could destroy our thriving world? Well, to find out the answers to all these questions, stay tuned till the very end of today's documentary. Every star in this universe that is born, it's not necessary that every star has a beautiful and complete family of planets and satellites like our sun. Some unfortunate, lonely, and aimless wanderers also exist who keep drifting here and there in open space. In such a case, if there is a star about 20 times bigger than our sun and it undergoes a massive explosion, then it takes the form of a black hole, although it is not like a typical black hole. In this universe, everything is dynamic dynamic, meaning every celestial body is in motion. In such cases, some black holes are especially stationary with no internal movement of any kind. But due to extremely massive cosmic explosions and some rare events, they can be displaced. Now look, in this universe, nothing is in a position of absolute rest. Every object is moving with respect to something or the other, so the difference is only in our frame of reference. Let me digress a bit and tell you something important. Well, till now, in all the videos you've seen illustrating the solar system, the movement of the planets is shown in simple elliptical orbits like this. Whereas the reality is far from this. In fact, all these planets follow this spiral pattern. Now, since our Sun is also orbiting the supermassive black hole present at the center of our galaxy, the Milky Way. That's why the relative motion of the Sun and all the planets will look something like this. Well, did you see how? It's just a frame of reference. Or in simple words, just by changing your perspective, the whole view changes completely. Now, let's get straight to the point. According to researchers, we have dug them up, and at any time, they can collide with any star. According to an estimate, about 5,000 light years away from Earth, there is just such a thing. Now, let's get straight to the point. According to an estimate, about 5,000 light years away from Earth, a dangerous black hole is lurking out there, but along with it, no such star has been seen. In the past, it has been studied several times by the Hubble Space Telescope, as a result of which we have obtained many important pieces of information about it, such as successfully measuring its exact mass. Now, many important pieces of information related to it have been obtained, such as its exact details. And that's when such dangerous black holes are born, which are roving by nature. They roam around in space searching for their prey. Everything that comes in their path gets swallowed up by the jaws of death. Well, 5,000 light years is quite a distance, so for now, let's move on. Now, this is the destructive black hole named Gaia BH1, which is present at a distance of only 1,500 light years from us. Although this is a typical black hole, it has its own companion star. In terms of mass, it is 10 times heavier than our Sun. Let's come to this point now. They make them dance to their tunes, constantly orbiting this star. And on the other hand, however, scientists' predictions stop even closer than this. Actually, some astronomers believe that the closest black hole to Earth is now only about 80 light years away. Now, will we be destroyed by coming into the grasp of that black hole? This is not entirely true. Black holes are not all of the same type. There are also many different classes among them. Therefore, even if we consider a black hole as a dormant, weak black hole. So let's get straight to the point now. Along with that, all life here would also end immediately. After this, the results that follow will truly be worth seeing. One by one, all the planets will start to break apart, and all the matter present in them will melt and flow into space. When the black hole comes, now even we will eventually be swallowed by that same maw of time. Therefore, this story can also take a happy turn. Instead of being a monster, it comes as a small primordial black hole. After the massive explosion of the Big Bang in the past, matter spread throughout the entire universe in varying amounts. In places where the amount of matter was less, the birth of these primordial black holes began. Now, knowing this, let's get straight to the point. These black holes started pulling in and accumulating the matter of the universe within themselves, and they have existed since that era, making them one of the oldest entities in this universe. You will be amazed to know that these black holes have existed since the origin of the universe, and they are among the oldest entities in this universe. It is said that their size can be as large as a big island. How much truth is there in these claims? But the universe is filled with these tiny primordial black holes. Even in our own solar system, it's quite difficult to determine their number, which could be in the thousands, but the science behind it is truly fascinating. So, as far as our Earth being destroyed by these black holes is concerned, for now, we don't need to worry too much about black holes present in the infinite universe. None are currently close enough to Earth to be a direct threat. No such black hole has been traced that could swallow our entire solar system. They are far away, and their basic principle says that instead of wandering around the universe, they stay in one place. While staying in one place, they pull everything around them into their grasp, and that's how their existence continues. But did you know this? Let's find out. Now the black hole will come very close to our Earth and pull us inside itself. What will happen during the year between the black hole reaching us and swallowing us? All of these events are about to happen. Soon we'll bring you a spectacular documentary on this. Also friends, if you liked today's video, don't forget to like it and share it with your friends. Also, if you are new to Documentary Library, subscribe and enable the bell notification so that you can get videos on astronomy and space science. Friends, see you again with another informative video. Until then, stay curious, be happy, and goodbye.